This is the 30 volt, 3 amp lab quality power supply, and this is part 2. I have not put the finished template on the front. This colored front panel consists of a cutout from this PDF. There is a link to the PDF in part 1 of this video. This case is what this template is designed to fit. This is a schematic of what I believe the finished power supply will look like. The line voltage will come into the IEC connector, which will be located on the back panel. There are 4 switching power supplies. All of the inputs to these switching power supplies are connected in parallel. You can see the black wire comes down and goes into 4 power supplies, as does the white. The outputs of the switching power supplies are a pair of power supplies connected in series. So whatever I use for power supplies, if they're identical, whatever the output voltage is, with 2 power supplies connected in series, the voltage applied to the next device, which is a buck converter, is twice the individual switching power supply voltage. The buck converter has all the brains built into it. Each buck converter has an output that goes to a pair of banana plugs, and I intend to put a reverse biased diode across each output. I may additionally put small capacitor or 2 in parallel with this diode. The switch, the buck converters, and the banana plugs are all mounted on the front of the case. That leaves us with 4 switching power supplies to be put in the case. I have accumulated 4 of these power supplies. These came from, I believe, Marlin P. Jones. What I've done is cracked one of these cases open, and inside I found this. I attached a white and black wire to what used to be the power connector, and I attached a red and black wire to what used to be the output connector. And I was very careful to make sure I connected the white wire to the same terminal on all 4 of these, and the black wire to the same terminal. That goes for the red wire on the positive terminal and the black wire on the negative terminal. Now, the ones I got from Marlin P. Jones happen to be new. I would recommend that in any event, whether they're from the recycling center or you buy them, that you do this to them and then temporarily hook them to 120 volt or whatever your native supply voltage is, and make sure they work. On the schematic, you will see that I've labeled the wire colors. These wire colors refer to these modified power supplies. Everybody has a favorite way to crack open one of these cases. My favorite way is to lay a box cutter in the crack and tap it with a hammer until I crack just the corners. I don't go any deeper than a little bit. You never know what's inside here, and you don't want to cut into a component. I do that to all four corners. I take a small screwdriver and pry open the case. I may test pry every once in a while to see just where it opens. Eventually I get a small opening. I go to a bigger screwdriver and the case cracks, and then I just peel it open. And there we have a cracked case. Almost as simple as breaking an egg. Now here we weren't in too much danger of hurting anything. If you look carefully, you can see where the knife actually put a little dent in the aluminum. Some of these switching power supplies do not have a wraparound heatsink. If you cut very deeply into them, there's a good possibility you'll engage one of the internal components. We don't want to do that. It's my intention to put 4 of these power supplies in here, in pairs of 2. It's going to be pretty tight. There's not a whole lot of room front to back. But that's not as important as the fact that these things don't fit height-wise on end, and will barely make it if I stack them on top of each other. Now, I cannot allow this aluminum enclosure to come in contact with this aluminum enclosure. So when I stack them, I'm going to have to put an insulating barrier between them. Once you've prepped your cases, and I notice they're slightly humped up in the middle. It's not perfectly flat. We've got some electrical tape in here. We want to stack these vertically. I have a total of 4, remember. And I'm going to blame my son-in-law, but he says this is the stuff to use. I've used it before, okay? And it does work. So I'm going to put a coating, not a coating, and I'm going to apply a row on each side. And maybe a row in the middle. This is a common index card. I'm going to lay 1 card on each power supply. I'm going to repeat the rows. I'm going to place the second power supply as carefully as I can. And I screwed that up. Goes this way. And I'll let it set overnight. The power supplies now are glued, I guess we could say, together as a module. They're insulated. I trimmed the excess file cord off, and I dressed the power wires so that they, when we put these against the back of the case, the power wires come into the center. I'm going to do all my wiring on some terminal strips, I think, in this area. I intend to move these power supplies back as far as I can. I'm going to leave the back in temporarily. It just lifts off. But I'm going to leave it in temporarily. And I'm going to hold the power supplies in place the same way as I glued them together. Power supplies don't extend above here. Mark this with a magic marker a little bit. And they don't extend more than here. And you've got to be careful not to cover up these holes that hold the case together. And here. Now I'm going to liberally apply the silicone bathtub caulk to each one of these little screw mounts. There's no sense applying any of the plastic or silicone caulk to the bottom of the case because of these extensions intended to receive screws. With a nice mounding of silicone on each screw, I can insert the power supply, slide it as far back as the case will allow it to go. Same thing over here. Slide it as far back as it will go. Then I'll remove the back panel. It was bowing slightly and exerting a force on these forward. I can't slide them too far back. And now I'll wait another day. But I do know that I can put the IEC jack centered on this back panel. So I'll do that, and I'll replace the template on the front with a brand new template. This is probably going to edit out to be about 10 minutes now. And I think I'll conclude this part 2. I'll do part 3, which will be completion of the power supply and a power up of it. And maybe I'll do a part 4 where I load test and maybe examine any transients that occur during the switching of the load switches. The load switches are built into the buck converter. Everything's built into the buck converter. That means, at least numerically, we're halfway through the construction of this dual output power supply. I'll see you again, hopefully, in part 3. If you have any questions or comments, leave them. I try to reply to them. Subscribe to my site or give me a thumbs up. I'd appreciate it. Thank you.